Hello dear students, today I will discuss about some questions from your miscellaneous exercise of chapter 11, that is three-dimensional geometry. Okay, so miscellaneous exercise on chapter 1. Miscellaneous exercise actually contains questions of different types from whole chapters, that is three-dimensional geometry chapters. So all the formulas just we have discussed in the previous classes will be used for solving these questions. The miscellaneous exercise contains different type of questions as usual from previous exercise. So here just I will give the idea how can you solve it. Okay, there are 23 questions and we have to solve all the questions. Here I will discuss about some of the questions and remaining questions you have to solve from yourself and by taking the help of reference book also. Okay, and examples, miscellaneous examples are very, very important. So remember and solve it. Okay, from your side. So first of all, suppose there is questions. So there are lines joining the origin to the point. This is perpendicular to the line determining the points this. So there are lines joining this is perpendicular. We have to show the perpendicular of two lines here. Solution of 1. What is given here? 1. Miscellaneous exercise. See here, origin to this is origin. Suppose this is what? Origin. Okay, just simple discussion here, like just like this. Suppose this is origin, so 0 0 0 is origin. Okay, and its point is 2 1 1. So 2 1 1 2 1 1. This is a point A. Okay, so this is a line and another line joining the points 3 5 minus 1, 3 5 minus 1. This is a point P and 4 3 minus 1. 4 3 minus 1. This is another point Q. This point Q, this point P. This is also line. Okay. We have to show that these two lines are perpendicular. We are not seeing as a perpendicular. Just we can like draw like this. Okay. Anywhere, just it is for only discussion. So this is a line. This is a line. We have to show that this line is perpendicular to this line. So how can we prove it? For perpendicularity of two lines, we know that if we know their direction ratios, A1, B1, C1, A2, B2, C2, suppose this A1, B1, C1 are direction ratios of this line and A2, B2, C2 are direction ratios of this line. Then they are parallel or they are perpendicular when? If A1 by A2 equals to B1 by B2 equals to C1 by C2, the lines is parallel. This is line L1, this is line L2. So line are parallel. If A1 A2 plus B1 B2 plus C1 C2 is equals to 0, this L1 is perpendicular to L2. Just we have to show perpendicular. So direction ratios can be found. How? You know, x2 minus x1, y2 minus y1, z2 minus z1. So direction ratios of L1 are what? U1 equals to x2 minus x1, 2 minus 0. This is 2, 1, 1. B1 equals to what? 1. C1 equals to what? 1. X minus x1, y2 minus y1, z2 minus z1. Similarly here, direction ratios of L2 are A2 equals to what? This is x1, y1, z1, x2, y2, z2. Then 4 minus 3. 4 minus 3 equals to 1. B2 equals to what? 3 minus 5. 3 minus 5 equals to minus 2. C2 equals to what? Minus 1 minus 1 minus 1 minus 1 equals to 0. Minus 1 minus 1 is plus 1. So here we have C1, A2, B2, C2. The ratios of this and this line are this. And we see that A1, A2 plus B1, B2 plus C1, C2 is equals to what? 2 into 1. 2 into 1 plus 1 into minus 2. 1 into minus 2 plus 1 into 0. 1 into 0 is equals to 2 minus 2 plus 0 equals to 0. Implies line L1 is perpendicular to L2. Okay, so just you have to write in details. So direction ratios of this line joining origin to this are given by this, and direction ratios of this are given by this, and here we see that this is equals to 0, that is perpendicular. Okay, now second question. Here second questions, generalized questions. L1, M1, M1, L2, M2, N2 are direction cosine of two mutually perpendicular lines, so that the direction cosines of the line perpendicular to both of these lines are given by this. Okay, M1, N2, Mn, NL, LL. Okay, so direction cosines here, just remember that there is a property, that is, just use this identity here, this type of identity we know. A1 square plus A2 square A1 square plus B1 square plus C1 square A2 square plus B2 square plus C2 square minus A1 A2 plus B1 B2 plus C1 C2 is equals to A1. Just this type of property is there. Okay. A1 B2 minus A2 B1 square plus B1 C2 minus B2 C1 square plus C1 A2 minus C2 A1 square. We know that. This is an identity, algebraic identity, just so you know. Okay, you can verify this into this minus this. You can also this in breaking these squares and some both sides are equal. So we will use this identity to find the direction cosines of a line. Here question 2. So here given the two mutually perpendicular lines. Suppose this is L1, this is L2. This is L1. Its direction ratios are, this is line L1, this is line L2. Mutually perpendicular. Its direction cosines L1, M1, N1. Its direction cosines L2, M2, N2. These are given. Mutually perpendicular lines. Because mutually perpendicular lines dash cosines. So, since L1 is perpendicular to L2, therefore what? L1 M1 plus L2 M2 plus sorry L1 L2 plus M1 M2 plus N1 N2 is equals to 0. Equation 1. Also, these are the direction cosine. If L1 M1 and L2 M2 direction cosines. Also, direction cosines. Just you have to write in your copy. Okay. What? L square M1 square N1 square. Sum of square of direction cosine is equals to 0. Not to 0. Sorry. 1 1. Okay. This is for perpendicularity. This is equation 2, and also L2 square plus M2 square plus N2 square equals to 1. This is it. Because of direction cosines. Just we will use this. We have to find now. We have to find direction cosine of a line L which is perpendicular to both of this line. Which is perpendicular to both of this line. This is in 3D space. Just we have to find direction cosines of a line L which is perpendicular to both lines L1 and L2. Okay? Let L, M, N, R. L, M, N, R direction cosine of L. Suppose direction cosine L, M, N. Then since L is perpendicular to L1 and L is perpendicular to L2 also, perpendicular to both. So this is L1, L1, N1, L1, L2, N2. Then what? L, L1 plus M, M1 plus N, N1 equals to 0. Perpendicularity of line L and L1. So we will get like this. And L, L2 plus M, M2 plus N, N2 is equals to 0. This is equation 4, this is equation 5. Clear? Now, this 4 and 5 can be solved. This 4 and 5 can be solved by cross multiplication method. So, this identity we will use. Okay. So, by solving 4 and 5, we can solve it. 4 and 5, 11 is there. So what? L by this, M by this, N by this, by cross multiplication method. L by M1 N2 minus M2 N1. M1 N2 minus M2 N1. Now M by N1 L2. N1 L2 minus N2 L1. And N by L1 N by L1 M2. L1 M2 minus L2 M1. By solving you can get like this. Now our target is finding 11. So here we can write. We know if three ratios are equal, then we can sum of upper side and lower side up. No, before summing, just squaring upper and lower side. L square upon just squaring upper and lower. M1 N2 minus M2 N1 square. Just squaring denominator numerator. M square upon N1 L2 minus M2 L1 square is equals to N square upon L1 M2 minus L2 M1 square. Okay, just squaring. Now, these three ratios may be written as equals to what? After this line, just we will use this all the condition. After this line, this ratio is equals to all the ratios are equals to these three ratios are equals to sum of numerator and denominator, that is L square A plus N square plus N square upon sum of lower side M1 square M1 N2 minus M2 N1 square plus just this. Here ratios are what? What ratios? This L1 square L square upon M1 N2 minus M2 N1 square. This is equals to this equals to this. Now here N1 L2 minus N2 L1 L1 M2 minus L2 M1 this. Now using this identity in place of L1 M1 N1 A1 B1 same. Suppose in place of A2 B2 C2 L2 M2 N2, then this quantity, that is this quantity, is equals to this. Here L1 M1 N1 square sum is equals to 1 because this is 1, this is 1. If we replace A1 B1 C1 A2 B2 C2 L1 M1 N1 L2 M2 N2, this is 1, this is 1 into 1 minus, and this is equals to 0. So this is 1. This is equals to 1. So we get this is equals to also 1. 11 direction cosines. So this is 1 upon 1 equals to 1. So all the ratios is equals to what? 1. So from here we can find the value of L. So all the ratios are equals to 1. So L square equals to what? This M1 N2 minus M2 N1 square. Similarly, M1 M square equals to N square equals to. Okay, so L square equal to M square. So we can get L equals to M1 N2 minus M2 N1. Similarly, all the ratios are equal to 1. So L equals to this, M equals to this, N equals to this. You can find lower part. N1 L2 minus N2 L1 here N1 L1 M2 minus L2 M1. So these are the direction ratios. Okay. So this is the required value of direction cosines of a line which is perpendicular to both the given line, whose direction ratios are L1 M1 N1 L2 M2 N2. Okay. So this is the theoretical portion of always. So this is used in these questions. So this is questions 2. Now question 3. Just I will discuss in short. Okay. So that maximum questions I can cover. and you have to solve all the questions in detail in your copy, because all the questions from miscellaneous exercise are important for your exam. So you have to complete the NCERT books, all the questions from NCERT book. Also do many questions from reference books. If some problem for solving the questions from miscellaneous exercise, just you can refer reference book. Okay. The question third: find the angle between the lines whose direction cosines ratios are this and this. So angle between the lines, direction ratios are given. We know two lines, 3D lines. Okay. So here question third, very simple. Your direction, there are two lines, L1 and L2. Direction cosines A1, B1, C1. Its direction cosines A2, B2, C2. Then angle between these two lines, theta, equals to what? Cos theta equals to A1, A2, B1, B2, C1, C2 upon root over sum of A1 square, root over sum of A2 square. A1 square means A1 square plus B square plus Cn square. A2 square means A2 square plus B2 square plus C2 square. So just use this formula in this question. It's very simple. So here A1, A, B, C are given. Here just given B minus A, C minus A. B minus C, C minus A, A minus B. These are the given. So direction cosine angle, if angle is, then we can see that what? A into B minus C. A into B minus C plus B into C minus C plus C into A minus B. Modulus of this upon root over A square plus B square plus C square, root over B minus C square plus C minus A square plus A minus B square. This. Here, by solving, you can get this is equal to 0. 0. So cos theta equals to 0. So theta equals to 90 degrees. So this is the answer, 33. Okay. So here, question third, 90 degree. Okay. Simple question. Question 4. Find the equation of line parallel to x-axis passing through the origin. Line parallel to x-axis, 3D line. 3D line parallel to x-axis and passing through the origin. Question 4. Okay. So for finding the equation of line, we require a point through which point pass and direction ratios of the direction of line. So here question 4, we can solve all the questions either in vector form or in Cartesian form. 4 questions. Line. 4 questions. We have to find the equation of a line parallel to x-axis. This is x-axis, y-axis. Suppose this is x-axis, this is y-axis, and this is z-axis. This is origin. Line parallel to x-axis. Line parallel to x-axis in 3D. Line parallel to x-axis. Okay, but line passing through also origin. So passing point we know x minus x1 upon a, y minus y1 upon b, z minus z1 upon c. This is the equation of straight line in 3D. Here line passing through x1, y1, z1. Here line or record line passing through origin also and parallel to x-axis. That is itself x-axis. That is itself x-axis. So a required line passes through origin and parallel to x-axis. So take a point upon x-axis as x-axis as a 0 0, because point on x-axis a x coordinate having some value a and remaining coefficients are 0. This is a point on x-axis. Now direction ratios of OA, direction ratios of OA, that is required line. Then direction ratios of OA are A 0 0. This is direction ratios. So the equation of required line passes through origin and parallel to x-axis. So that is x-axis itself. Okay. So the equation of x-axis is x minus y and x1 y and z1. That is a 0 0. A upon a equals to y minus 0 upon 0, z minus 0 upon z minus 0 upon 0. So implies, passing through point origin, take passing through point origin and this, so x by a equals to y by 0 equals to z by 0. So our required line is given by, what is question number 4. And if all are equal to lambda, so we can write x by 1, a go to the lambda x by 1 equals to y by 0 equals to z by 0 equals to lambda a. So implies x by 1 equals to y by 0 equals to z by 0. So this is our required line, equation of line. So here we can see that the answer is what? X by 1 equal to y by 0 equal to z by 0. Okay. Now, question 5. Question 5 is, if the coordinates of the points A, B, C, D are this respectively, then find the angle between the line A, B and C. These are very simple questions. You just do from yourself in your copy. Okay. Simple questions, because just we have to find between angle between two lines, and lines are given by the joining the 2 points out of 4 points, and other line is also given out of the remaining joining the remaining 2 points. So here 4 points are given and also the coordinates are given. So simple question. For solving question 5, A is given, B is given, C is given, D is given. So here what? ABCD. So ABCD, angle between the line. So these are given always. Pointer given, here pointer given, here pointer given, here pointer given. Just you solve it from yourself. Because ABCD, angle AB, angle CD, just we have to find the angle between these two, AB and CD. So how can you find the angle? Cos theta equals to, if direction ratios of AB is A1, B1, C1, then A1, A2 plus B1, B2 plus C1, C1, C2 upon root over A1 square sum root over A2 square. This is the formula. A1 B1 C1 direction ratios A1 B1 C1 can be found by using x2 minus x1 y2 minus y1 z2 minus z1. Similarly, x2 minus x1 y2 minus y1 z2 minus z1. Then you can get A1 B1 C1 A2 B2 C2. Okay, A2 B2 C2. Just use these values here and you can get here. Clear? So simple process, so you can do it. Okay, so find the angle, complete these questions in your homework copy. Okay, now question 6. If the lines these are perpendicular, then find the value of k. Lines are perpendicular. If lines are given like this, 6 questions. Here lines are, what are the equation of line? 1 2 3 minus 3 2k 2. First line x minus 1 y minus 2 z minus 3 upon this. This is first line. What is given? Minus 3 2k 2. Minus 3 2k 2. First line. Second line is what? Minus 1 minus 6. X minus 1 y minus 1 z minus 6 upon. This is second line. Second line is given 3k 1 minus 5. 3k 1 minus 5. This is second line. Just these two lines are perpendicular. These lines are perpendicular. We have to find the value of k. Our standard equation of a straight line is writing like this: x minus x1, y minus y1, z minus z1, x minus x1, y minus y1, z minus z1 upon ABC. ABC are the direction ratios of the line, and x1, y1, z1 are the points through which straight line pass. So here its direction ratios are what? Minus 3 2k 2, and its direction ratios are what? 3k 1 minus 5. Just you have to write in the standard form, and then you can write. The standard form means coefficient of x is 1, coefficient of y is 1, coefficient of z is 1. Okay, x minus x1, y minus y1, z minus z1. Then denominator ABC. So these are the A1 B1 C1, A2 B2 C2. This is A1 B1 C1. This is A2 B2 C2. These two lines are perpendicular. So this is line L1, this is line L2. So L1 perpendicular L2. That means what? A1 A2 plus B1 B2 plus C1 C2 is equals to 0. So solve it. A1 A2 minus 3 into 3k minus 3 into 3k plus B1 B2 2k into 1 2k into 1 plus 2 into minus 5 is equals to 0. So from here we can find the value of k. Just minus 9k, here 2k, here 10. So minus 9k plus 2 minus 7k. So minus 7k is equals to 10, means k equals to 10 by 7, minus 10 by 7. So value of k is minus 10 by 7. Okay. Now question 7. Question 7 is given as find the vector equation of the line passing through the point and perpendicular to the plane. Just we have to find the equation of line. Question 7. Find the vector equation of line passing through the point 1 2 3 and perpendicular to the plane this. We have to find the equation of line. Okay. Question 7. We have to find the equation of line. Clear? So equation of line means we require passing point and direction ratios of the line. Okay, so here direction ratios of the line can be found by using the condition. In the question, the given that find the vector equation of the line passing through the point 1, 2, 3. Vector equation. So we know vector equation of line is, this is vector equation of line is this. Okay, question 7, where this line passing through the point A having the position vector A and parallel to vector B, this line, that is direction ratios can be taken from the vector B. So here given point is, so required line passes through the point what? 1, 2, 3. 1, 2, 3. 1, 2, 3. So it's and its position vector is OA is equals to what? I 1 into I plus 2j plus 3k. That is vector A. Vector A. Okay, vector A equals to this. Now, since the required line is perpendicular to the plane, what is plane? Line is perpendicular to the plane r dot 1 to minus 5, r dot 1 to minus 5 is equals to plus 9 equals to 0. Plus 9 equals to 0. This is the equation of plane. Line, the required line is perpendicular to this plane. That is, line is parallel to the normal to the plane. And parallel line having same direction ratios. So direction ratios of the plane may be taken as the direction ratios of the line. This. And direction ratios of normal to plane are what? Direction ratios of normal to plane are 1 to minus 5. 1 1 to minus 5. So the line is parallel to the vector B is equals to I plus 2j minus 5k. So we get the value of A and B. So we can write the plane. Thus, the required line is given by what? R equals to A means this. I plus 2j plus 3k plus lambda of B means this. I plus 2j minus 5k. So this is our required line. Okay. So solution of question 7. We can say question 7. 1 to 3, 1 to minus 5. Clear? So using formula for a straight line and for normals and different type of formula you can use for solving questions. Just use formula in proper way. Okay. Question 8. Find the equation of the plane passing through the point ABC and parallel to the plane this. Find the equation of the plane. Question 8. We have to find the equation of the plane passing through the point and parallel to the plane this. Just we can find equation of plane. There are three types of formula for finding equation of plane. Plane passing through a point and perpendicular to a direction. So here just it is given that in question 8 we have to find the equation of plane which passes through ABC point ABC and parallel to the plane. Plane parallel to the plane, that means normal to the required plane is perpendicular to the given plane. Is perpendicular to the given plane because plane is parallel to this plane. Clear? So normal to the required plane is perpendicular to the given plane. Also normal to the required plane is parallel to the normal to the given plane. That is, from given plane, just we have to find the direction ratios of the normal to the plane. And that direction ratios of the normal can be used for normal to the required plane. That is, direction ratios are same as direction ratios of normal to the given plane for the required plane. Okay, so here for finding normal to the required plane, we can write the vector n as taking normal to the given plane. Okay, so here question 9. Now 8 question. So here just like line parallel to a straight line in two-dimensional geometry, just we change only. Suppose 2x plus 3y plus 5 is equals to 0. This is a straight line in two-dimensional geometry. Then for writing parallel straight line, just we change only constant term. So here also for writing equation of plane parallel to a given plane, we can write in vector form as well as in scalar form, the Cartesian form with different constant. So here given plane is question 8. The required plane is parallel to the plane R dot I plus j plus k is equals to 2. So we can write the equation of required plane as r dot I plus r dot I plus j plus k is equals to lambda. Just change constant. This plane r dot n equals to d. This plane is parallel to the given plane. And also there is another condition. Find the equation of the plane passing through the point ABC. So this is our required plane. If it passes through ABC, ABC, that is A. OA is equals to AI plus BJ plus CP. In vector notation, position vector of this point A. Then it will satisfy this. That means OA will satisfy this. That is for arbitrary vector. Here, just you have to write this AI plus BJ plus CK dot I plus J plus K is equals to lambda. This condition. So from here we can get value of lambda. So just take its dot product. So A plus B plus C equals to lambda. Put the value of lambda in 2. We get the required plane as, just put the value of lambda here, r dot I plus j plus k is equals to a plus b plus c. This is vector equation of plane, of our required plane. Okay, so here equation of the plane, the vector equation. And Cartesian equation we can write Cartesian equation xi plus yj plus zk dot I plus j plus k is equals to a plus b plus c. Implies what? X plus y plus z equals to a plus b plus c. This is Cartesian equation, this is vector equation, the required plane. Okay, so question 8 is this. Okay, in similar logic, by giving similar logic you can find solution of all the remaining questions from of this exercise. The next question is for question 9, find the shortest distance. So remember the formula for shortest distance between two straight line in 3D. What is the formula? Formula is, what is formula? Formula is given by b1 cross b2 dot a2 minus a1 upon mod of b1 cross b2 cos theta equals to, first shortest distance equals to, because shortest distance formula is can be found, shortest distance can be found between two straight lines. Here straight line is given. Find shortest distance between the lines. There are two lines are given and 10 questions. Find the coordinates of the point where the line through this and this crosses the YZ plane. So simple question is only formula based question. Question 10 and 9. Question 9 only formula based questions. Okay. What is the formula for finding shortest distance between two lines? Shortest distance between two lines like this. Question 9. Shortest distance is equals to what? Mod. Just B1 cross B2. Two vector. This is vector cross product. And A2 minus A1 vector upon mod of B1 cross B2. This is formula of shortest distance between two straight line. Straight line can be given R equals to A1 plus lambda B1. Second line R equals to A2 plus lambda B2. This is our equation up to a straight line. Equation up to a straight line, this line passing through the point A, whose position vector is A, and parallel to the vector B1. This is A1, 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 its position vector. This line is passing through the point A2, and its position vector is A2. And this line is parallel to B2. In this, then the shortest distance between these two lines, when these lines are not intersecting. Okay, so this is formula. Just from the question, comparing, because in given straight lines, two straight lines are given. So here, question 9, comparing with this, we can get A1 6 to 2. Comparing to the standard form. Of straight line, we get A1 equals to A2 equals to B1 equals to B2 equals to A1 equals to what? 6 to 2. 6i plus 2j plus 2k. And A2 equals to second line minus 4 minus k. Minus 4i minus 4k. Minus 4i minus 4k. And here lambda mu and just 1 minus 2, 2 is 1 minus 2, 2. 1 minus 2 z plus 2k. 3 minus 2 minus 2. 3i minus 2z minus 2k. Just compare with this. Then you can get this 3 vectors, 4 vectors. Just now find the value of b1 plus b2, b1 plus b2 by taking value. Simple. I, j, k, 1 minus 2, 2, 1 minus 2, 2, and 3 minus 2, minus 2. You can solve it. You can get a vector. Okay. And also, you can find a2 minus e1 as a vector. Just take its dot product. Then you can get the value of this. And also find modulus of these vectors. Just use here. Then take positive value. That will be the shortest distance. Okay. Only formula based questions. So do it in your copy. Okay. Question 10. Find the coordinates of the point where the line through point 516 and 341 crosses the YZ plane. YZ plane means what? YZ plane means x equals to 0. X equals to 0 because in YZ plane the value of x coordinate of all the points are 0. So suppose this is y, this is z, this is x axis origin. This is YZ plane. In this plane value of x is 0 and y1 z1 having some value, but value of x is always 0. So we have to find the point this p, y1 z1. Clear? And line crosses this plane at this point, and line passing through the point what? 516, 516. This point A and 341 and point 341 point B. This line passing through these 2 points. Okay. So how can we find the point? So line passing through 2 points, we can write line passing through 2 points, x1, y1, z1, take it b1, c1, and x2, y2, z2. Our required point is this. Okay, is given by line what? X minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1 equals to z minus z1 upon z2 minus z1. Okay, so this is x minus x1. x1, just if we take this is x1, y1, z1, this is x2, y2, z2, then x minus x1 5 upon x2. x2 means what? 3 minus 5 equals to y minus y1 what? 1 upon 4 minus 1 equals to z minus 6 upon 1 minus 6. So we can write like this: x minus 5 upon minus 2, y minus 1 upon 3, z minus 6 upon minus 5 equals to k. Say, suppose these 3 ratios are equals to k. Then any point on this line passing through these 2 points, the straight line is this. 3 ratios are equals to k. Say, any point on this line is any point on this line can be taken as what? X equals to minus 2k plus 5, minus 2k plus 5, y equals to 3k plus 1, 3k plus 1, z equals to minus 5k plus 6, minus 5k plus 6. This is any point on this line. Now, line crosses YZ plane at P. So, if line 1 crosses YZ plane at P 0, B1, C1. Then, because P having x coordinate 0, then this is equals to 0. Minus 2k plus 5 equals to 0. So here minus 2k equals to minus 5. That is k equals to 5 by 2. So our value of k is 5 by 2. Now first coordinates 0. We require B1 and C1. So B1 equals to B1 equals to what? 3k plus 1. 3k plus 1 equals to 3 into k means what? 5 by 2. 5 by 2 plus 1 means what? 15 plus 2 by 2. 17 by 2. And C1 equals to this. C1 equals to minus 5k plus 6. 5k plus 6 equals to minus 5k. K means what? 5 by 2. 5 by 2 plus 6. Here minus 25 plus 12 minus 13 by 2. So beyond C1 is here. Therefore, required coordinate is what? First value 0, second value 17 by 2, third value minus 13 by 2. So this is required coordinate, and this is our answer. Okay, so you can see the question 17 by 2 and minus 13 by 2. Okay. So in a similar fashion, you can do all the questions from this exercise by taking help of from reference book, and if any doubt you can ask me. Okay, so send me some solution of questions just you have done in your homework copy for your attendance. Okay, just complete this exercise, miscellaneous exercise, and example also. They are important for your exam. Okay, so send me PDF file for your attendance. Okay, today this chapter is completed. Okay.